My name is Ryan Gravett, and we're going to be talking about the Progress MoveIt cyber attack that resulted in one of the largest cyber attacks in history. The MoveIt software itself was designed to allow individuals to transfer files securely, so many organizations and institutions used it from their most sensitive information, thinking to themselves that this was a very secure way of transferring those files. And if it was designed properly, it would have been. Unfortunately, it wasn't, and as a result, over 2,600 institutions were impacted by this attack, and these included banks, universities, and health information, with our most sensitive information, our financial, our academic, and our health information being released to the public and being held for ransom. In the end, over 90 million individual user accounts were compromised as part of this process, and over $100 million was delivered as ransom to the CLOP security group. Now, on the offset, this looks like a SQL injection attack and a data transfer, but if we drill down much deeper and take a look at logs, we can see that this is a series of different attacks that resulted in the data transfer and the information being exploited. Let's dive deep and take a look at these different ones and what could have been done to protect against it. The first one was session variable manipulation, and what happened is the attackers leveraged some error in the coding of the MoveIt is API DLL, and we're able to add in session variables. Now, these session variables were injected in the headers, and the server then, they were able to get the server then to store them as if the server themselves created it. Obviously an issue. This was then pivoted into the next portion of the attack, which created a cross-site request forgery token. This is designed to only allow the individual user to take actions on the page that they were on using a browser, but this bypassed this whole process entirely by getting that token. Again, they utilized that session information and then passed information into one of the arguments, and were able to, through this guest access at ASPX, extract information on the token. This token was required then, and by far allowed the attackers to automate this process. Without it, they could have probably done it with an individual user exploiting the SQL injection on a web page itself, but this allowed the automation of that process to occur, greatly impacting the scope and impact of this attack, as we'll see later. The next one was the SQL injection attack itself. They put this information in session variables and then executed it. Again, we can see some of the SQL here that was ran by the attackers. We can see, of particular note, the ability to add in a login name and an external token authority into the database itself. And so not only was the database itself compromised through the SQL injection, but the ability to store this information, like private key information about this external tokens, was a big issue as well. The rest of this code allows IP addresses to be added in for that external token authenticator and token provider, and then also the URL of that as well. When we take a look at the actual injection that occurred, we can see the comma that was added here, and then the commenting at the end, and then the SQL information that was added. So just a simple failure to sanitize those inputs was resulted here. In this case, the package self-provision receipts was a field that allowed multiple email addresses to be added to get a confirmation that a file was successfully sent. They actually went through and pulled out commas to identify which one of those were individual email addresses, and that code does pull out any of the commas, so the SQL statement can't include any commas, which makes it a little bit more tricky, but obviously with time the attackers were able to do that. It's interesting here, though, because it's likely the fact that additional code was taken on this particular field to parse out those comma delimited information, that they forgot to do some of the sanitization that they generally would do otherwise. And so as a result, this particular field had that issue, and of course passing some of the session information in through those headers allowed this attack to occur as well. Finally, the weak verification of JWT tokens was an issue as well. The users then took the information that they gathered from the database and created a Java Web Token with that super admin access. Now, this is an issue, of course, even just associating and giving this token, but I want to also go back to talk about a little bit about the privacy of that private key that was stored in the database that shouldn't have been stored in the database in the first place. So they were able to then get a Java Web Token have an administrator user on that account. And from there, it was pretty much just covering their tracks with an additional SQL injection and then going through and getting remote code execution. The way that they did this is they started a file upload, then went back into the database, injected the payload of the file that they wanted executed, and then triggered the resumption of that file upload again. And as a result, any code that they wanted to be ran could be ran on that server. So we go from pivoting from having full database access to actually having full control of the machine itself, where all those files are stored and all the information is stored. From there, it was fairly trivial for them to add a new ASPX page that allowed persistent console access and allowed them to extract files remotely and store those files. In the end, the attackers ended up putting up a ransom, and as we saw, that ransom was very successful. They said, you've got to pay within a certain amount of time. Very traditional here. The exploit actually occurred in May 2023, but if we took a look at the timeline, we can see some of this code being tested, and you can see some of the logs there. They clearly sat on this code for some time, as when we take a look at some of the first exploits that occurred, we see the log files going back all the way to 2021, when the SQL injection portion of this was being exploited and tested manually rather than in an automated fashion. So clearly, they started with that SQL injection and then moved on to finding the other vulnerabilities in this software to automate the full thing. And then did it on the Saturday of Memorial Day weekend, giving them a 3-day weekend to allow that exploit to occur before anything could be done and patched on the following Tuesday. Progress released information on it and some patch information. But as you can see from the timeline, obviously a lot of clients failed to patch, even though that was released within those first, fairly shortly after that. So some big issues there. Also interesting enough is going down in, let's take some time and go down into the details of what could have been done to protect against each one of these issues that we identified. So the session variable manipulation, we need to be doing input validation on that. We need to be restricting external modification of those. We shouldn't allow the client to create server-side session variables, and that was a big issue from the beginning. The second part of it is that cross-site request forgery token really needs to be bound to a legitimate login. We shouldn't allow that to be created by an external party and then ran by an external party. So that allowed that token to be pulled and then reused again. The other portion of this is the SQL injection, of course, the parameterized queries and input sanitization. Both of those were not taken on this, and both of those items would have protected against this. And then finally, the weak verification of that JWT token. Really, that private key information shouldn't be stored in the database. It should be stored in a key store. And if it were, then of course, there would have been database access, but not full admin access, or it would have been much more difficult to pivot the attack the way that they did. And then they also should verify the token providers as well. In the end, this is a supply chain attack, and some organizations like the University of Utah were hit 3 individual times because they had 3 individual providers that relied on that information. The National Student Clearinghouse and TIAA-CREF were both clients of theirs, and they got hit multiple times. Students only saw that the University of Utah leaked their data, but so what could the University of Utah done when it's a 0-day attack against a known provider or a supply chain that they use for transferring files? Really what it comes down to is defense in depth. Some organizations were able to detect that files were being transferred at the network level and stop it before it continued on. They were able to detect this because of the physical or the network or the computer resources that they had to detect anomalies or activities that were outside of expectation. So really, this is a big focus on our organization, that we can't just rely on the application and the coding to be done well. We have to think about defense in depth and expect security at all levels to be able to protect against attacks like this. Thank you very much for your time.